All right, recording in progress.
All right, you guys can see that, right? And just that, and nothing else.
Yes.
Don't wanna share everything.
Yep, I see like the white slide with the text like computer graphics in the game industry.
Yeah. We can kind of start whenever. If you want to give it like another minute or two for people to trickle in or something.
Yeah, well, I would say like if you feel ready to start, like we can get started now since we started recording.
I guess that's fair. Okay, so hey everyone. I'm Ben Quach. I am a graphics engineer in the video game industry. I work at EA. Previously, I attended UCR from 2012 to 2016, which is a long time ago at this point. And I have a few slides for this. So I should just start with that slide. Okay, yeah, I currently work as a rendering engineer at EA. I work on a game called Battlefield Mobile. I'm primarily someone who works on mobile stuff nowadays. That's kind of my area of expertise. That's kind of where I kind of started in the graphics industry. I previously worked at Samsung. I was a graphics driver engineer. So I worked on mobile phones, like the GPUs and stuff for mobile phones. That was a very game adjacent field because people nowadays use their phones and that stuff to play video game stuff. So I was working on performance and implementations and stuff for graphics drivers on the phones, and I used to also work at Autodesk. And you're probably familiar with Autodesk if you use Maya, 3ds Max, all that fun stuff. That software is like 40 years old at this point. It sucks. But it is also the industry standard. So you don't have a choice, and it's really expensive and it's really complicated. Super good, but yeah. So I've always been kind of in this, basically in the sphere of computer graphics, computer rendering, all that fun stuff. Technically, this is my first job in the game industry with like an actual game product. When I was doing graphics driver stuff at Samsung, we would do a lot of game related stuff, game adjacent stuff, like making sure games run fast on the phone. But this is the first job that I've had or work directly on a shippable title. Okay, so previously, yeah, I was the ACM president from 2015 to 2016. I was also the treasurer of ACM before that. And then I used to be the Gamespawn vice president in 2014, 2015, which is when Gamespawn was created, actually. So technically, I'm a founding member of Gamespawn, or I was a founding member of Gamespawn. So I was a very busy boy those years. Definitely skipped out on class a lot to do some of that stuff, but so yeah, this is some pictures of us, mostly ACM related. I don't know if ACM is still like that popular amongst CS students nowadays, but ACM was pretty big when I was there. It was mostly just like a club for a bunch of CS students, and I'm a CS major, or I was a CS major. I used to write a lot of games in my spare time. It's on GitHub and stuff, but it's like 10-year-old games at this point. A lot of old games. And I was technically treasurer of Highlander Gaming too, back in the day, back before it was cool. It was like a very small organization back then. So I did a lot of extracurricular stuff in college. Okay, so what's next? Okay, so what is computer graphics? So most of you guys are kind of aware. If you're making like a 3D game or a 2D game, you're putting some stuff on the screen and it's supposed to look a certain way, right? And I use like the term rendering and computer graphics kind of interchangeably. They're technically different because computer graphics is just the whole realm of like the process in which we like display stuff on the screen, and rendering is more of the how do we make it look at a certain art direction. Like if you want like a photorealistic look, like how do we translate those pixels into something that looks like we want it to, right? So this is like a screenshot of Doom 2016. which is, you know, a pretty advanced piece of technology for its time. And it takes a lot of work to get like that visual fidelity. So in order to, so in rendering, when we render like a video game, typically if you want like a photorealistic game, or something along those lines, we're trying to like simulate the world basically, right? Like a big, I forgot to put in pictures for this, but basically like if you have, I don't know if you guys have ever tried this with like Unity or Unreal, but if you have like a game and you like disable all lighting, right? It's like flat. It looks like it's just like super flat, right? It's just a bunch of color. It looks not that great. What makes it look good is lighting effects, right? Is that you know, you see like on this screenshot here. I don't know if you can see my mouse. There's like a bunch of lighting effects. There's like the specular here. There's like the lights glow. That's what makes a game look good, right? That's a really important part of what makes a game look good. And that's actually a really complicated effect to do because you're trying to simulate light and like all these photons and stuff around that bounce around is like super complicated. They do a lot of things that computers can't really handle. So we're just trying to simulate or pretend to simulate the world, right? Because honestly, we cheat a lot in games. Yeah, basically we have these things called rendering algorithms that we use, which is basically like, hey, this is an algorithm that we use to try to make this thing look a certain way, right? Or try to follow some rules in order to generate the look, and then we can tweak that look so that it follows the art direction of the game. So yeah, that's what I work on. I work on making stuff look as good as it can with the constraints that we have. So there's a lot of applications and fields for computer graphics. Obviously, games is one. It's a really big one. There's also movies. So Pixar, Disney, they have all these like super advanced, super, offline renderers that make, Toy Story and all these like movies look as good as possible. That's a really big application of graphics. Then there's like engineering and CAD software. So this is like AutoCAD, which is like a design tool that you use to design buildings and stuff. That's actually what I worked on when I was working at Autodesk. I worked on this piece of software. Horrible piece of software. The code is like twice my age at this point. And then graphics drivers and hardwares, making the GPUs. And yeah, the GPUs that like 3080s or whatever that makes your computer run fast. Okay, so but primarily here we're talking about video games, and video games is honestly, if you want to get into graphics and rendering, video games is the place to be, or movies. That's where everyone's trying to be. So what are we trying to do when we talk about like computer graphics and all this stuff in video games, right? So the biggest problem is that we want real-time FPS. We want like a full interactive game that like runs well and stuff. Like you dump like out, like you guys are in college, so you probably don't have a lot of money. But I dump like I have like a 3080 Ti, right? It cost me like $1,200. It's pretty expensive. Why would I dump that much money? One, because I can, and two, it makes your games run. You can run games faster, right, and look better. And that's a really big goal of of graphics in the game in the game industry, is that we want games to look as good as it can for the frame rate that we can get, right? And then the thing is that like games have a lot of interactivity and like animations and stuff, because that's kind of like the appeal of the video game, right? You can go in there, you can shoot stuff, it looks cool. There's lots of explosions, a lot of fun stuff, right? We also want to iterate quickly. So the thing is that like when you're doing graphic stuff, like your biggest client is like the artists, right? So one of the things is that like that I learned, and I was also told this, is that like the faster your artists and your content creators can iterate, the better the game will be. Which is like a really important thing, right? If your artists can iterate really quickly, they can achieve the sort of look that you're going for. And that makes your game look better, makes your game play better, and obviously still doesn't look good. So yeah, you probably play games like man, what's like the cool game nowadays that like looks really good? Like I know like back in my time it was Crisis. Um shit. There's probably like a game out there like that
Borderland?
tries what's that?
Borderland?
I don't know if Borderlands is like it's a very stylized game for sure.
Okay.
And
Oh
there's
yeah.
um there's a lot of things that they can do. But if we're talking about like the most photorealistic, the most, intense game you can like have, probably Call of Duty, I'd say. I think Call of Duty has been on the forefront of like games that look as realistic as possible while running as quickly as possible. That was probably the case like 20 years ago too, actually. They make a lot of money. So yeah, this is like a different like problem space, right? Than like movies and stuff. Because movies you have like it's you don't have to like deal with interactivity and stuff. So how do we get this? How do we get this effect, right? So we cheat a lot. Honestly, if you're interested in going computer graphics, basically you need to the main things that I learned is that like one, the human eye can only process so many things, and if the human eye can't process it, you can ignore it. So you want to cheat as much as humanly possible. I know like back when I was in school, I was like, oh man, dude, this is like not the right way of doing it, right? Because we're like, this is like a hack. Like like I used to write like a lot of like game engines and stuff in school. Because Unity and Unreal Engine were like a thing back when I was in school, but I was too cool. So I just wrote everything in like C++ and stuff. And I was like, oh man, dude, when I implement this like rendering thing, right, it feels wrong because it's not actually doing what it's supposed to do, like simulate light. It's just like a hack. But it turns out everything you do in video games is a giant hack. We're cheating a ton, like because honestly, light interaction is really complicated. We can't do that in real time. So if you guys see here, how many of you guys are familiar with like normal maps, right? Have you guys just used like Unity and Unreal Engine a lot? It's kind of awkward because
Not,
like
not
I'd say-
this before. Yeah, I mean, I've used with like Unity, but it's most like wireless or wired map, but probably not normal maps.
okay. So oh crap. So if you do like more of the 3D stuff in like Unity and Unreal Engine, and they support all this stuff, they have all these things like normal maps and stuff, which like simulate things on the it changes the light interaction, and normal maps don't exist in real life. It's just something that we came up with, that game engineers and rendering engineers came up with to like render higher detail faster without actually having to render that. And then you see like SSAO. This is like it's called ambient occlusion. I don't know if you guys are super familiar with this as well, but you see on the left, it's like super flat. There's no SSAO. And on the right, there's like this shadowing effect here. Looks a lot better. This is unrealistic. Real life doesn't have this, but we have it, and it's not realistic at all. It's just something, but it looks realistic, right? We're cheating. So we cheat a lot in games. Yeah. And so if you guys are familiar with like Unreal Engine and Unity and stuff, you guys probably do that. You guys probably don't have to worry too much about all these like details and stuff because the game engine handles it for you, right? However, the more we do, like the bigger the studio, the bigger the project, we do end up specializing more. And basically, these engines are not perfect. Personally, how many people here have like used Unreal Engine? No one?
I think we used to have an Unreal Engine workshop, but we haven't had it in a while. Oh, Diane. Diane has.
Okay. The thing is, I hate Unreal Engine. Unreal Engine sucks. I hate Unreal Engine. Oh my god. So we use Unreal Engine. I use Unreal Engine at work for the game I make, which is Battlefield Mobile. That thing. So a lot of the things with these like this Unreal Engine and Unity and stuff, these renderers, they work really well for prototyping. Like they work out the box. The problem is they work out the box for like literally everything. So if you have like a very, AAA game with a lot of effects and stuff, it doesn't work that well. Because at that point you're like really trying to optimize everything, and then you're like working with this render that's like trying to do too much. So the bigger the studio, the more people specialize, right? And that's why people like me exist. Like basically, I work specifically on graphics. I don't really touch too much of gameplay unless it like interferes with like performance and stuff. I don't really touch too much with like other parts of the game, like networking. I don't know anything about that. So don't ask me, but I do know a lot about computer graphics and performance. So basically, someone like me, we work on like specific requirements for the game, right? So there might be shaders. Are you guys familiar with shaders at all? I know like Unity and Unreal, like they have like these things, and if you want to like have a certain look for your game, you stylize the game. But that's kind of what shaders do. So I implement those things, and then we like basically try to make the game fit like the art direction that people want. Performance, that's a really big thing. There's like a chat. I need to like actually have the chat open. Performance, really big thing. The bigger, the more, the like, these games, these AAA games, that come out, they're like have insane amount of assets. So they need to run fast in order to make, in order to have all that stuff on the screen. And yeah, the bigger the studio, the more specialization, because you just need to spend more time polishing. At EA on the studio I work at, we have like a ton of gameplay engineers. We have, in my opinion, too many gameplay engineers because we need to hire more rendering guys. We have people doing specifically security, physics, audio, because that's what it takes to like polish the game, right? It just takes a lot of people. And the studio I work at has like 150 people, and we're like desperate for more. We're really desperate for more. So but yeah, the bigger the studio, the more work, right? The bigger the game, etc. When I was working on games, in college and stuff, we could, we wouldn't have like these huge scale games. We just work on stuff that we kind of want to do, so we could get away with like less people. For a commercial product, it's real hard. I know, like, you guys know Star Citizen. Yeah, that company has a lot of people because of the scope of the game, right? They have like an absurd number of engineers. Actually, kind of on a side note, I was really excited for Star Citizen when I was in school. So it hasn't come out yet, so but yeah. So what I work on specifically, I work on mobile phones. So you guys probably played Genshin Impact at some point. Genshin Impact, you probably don't play on your phone, but it does run on phones. And it runs real bad on phones, actually. And I work on a Battlefield game. It's real tough to make it work on a phone because phones have different considerations. I don't know if people here are like super into mobile gaming. I got really into mobile gaming because all the anime gacha games are on mobile. I have a real short attention span nowadays for playing like actual games. So I spent a lot of time playing games on my phone. And mobile phones getting more popular. I worked at Samsung, so obviously I worked on a lot of mobile phone GPU graphics stuff. But it also is less mature, which is a polite way of saying it kind of sucks. It just doesn't have the power, just doesn't have the tool set. So primarily what I work on is performance. I work on performance a lot. Rendering is like 30%, cool lighting effects, 70% making those lighting effects run at 60 FPS. So yeah, I do a lot of performance stuff. So I work on like a Battlefield game, right? And a Battlefield game has a lot of destructibility, has a lot of like big open maps, a lot of vehicles, a lot of people blowing stuff up. This is a real problem in terms of performance, actually. It's like a serious problem because like these big open scenes, hard to render at a good frame rate, and all these explosions and stuff blowing up, also hard to render. So we're that's kind of what I'm trying to make sure. We cheat as much as possible. If you're like, so like Call of Duty, right? If you ever played Call of Duty, it's like a very linear game, right? If a linear game, you can cheat a lot because you can control like what the player sees. So everything outside that you can pretend it doesn't exist. It's a lot harder with a big open world game. So that's kind of what I work on. So we're cheating a lot right now. I have a lot of cool ideas to make it faster. I just haven't done it yet because there's not enough of us. But yeah, performance is the big thing. If you're working on just like a game, it's like Unity on your engine, and it's a pretty small game, you probably don't have to worry too much about performance. A lot of the game engine probably takes care of it. Unreal Engine does not take care of it for us because Unreal Engine is not good on mobile. So I gotta do a bunch of extra work, and just support more devices and phones because a lot of people have pretty bad phones and people want to play Battlefield on them. Implementing material shaders, so stuff that makes the game look good visually, like lighting effects, like I mentioned, lighting, that's post-processing effects, a bunch of cool flashy effects to make the game look good. And then we want to add a bunch of settings and stuff so that artists can like tweak it and make it look as good as they want. So that's the other thing I work on. But this is like way less right now than like performance. Performance is like insane for us. I'm sure you guys have played like games that like run real bad. Like you guys probably played Battlefield 2042, right? Game runs like really bad. It doesn't run good. I have like a $3,000 computer. That I should be having way more frames on that computer that with Battlefield 2042. But I don't because it's poorly optimized.
Yeah, I have a PC that when I was trying to run the game, it was not running well, even on low. And I was like, oh, my hardware is actually out of date or something.
Yeah, it's not. I don't think it's a hardware out. Well, it could be out of date, but
I thought it was at first, but I was like, wait a minute, I don't think it should be.
yeah, I know that like we're like Battlefield 2042 is like way. It's not hitting any of its performance targets right now. Performance targets, so it's hard. But this is in general for a whole game. The whole process, this is kind of like the whole process of getting like your 3D model you make in like Blender or something to the screen is that the biggest one is art. So obviously artists and stuff, they make the cool models and stuff. And then tech art is like a very specific thing to games. They help get it into the engine, which is more complicated than you think because like when you're just working with the engine normally, there's like importers and exporters with like your models and stuff, so it's pretty straightforward. But like with other games, you add a bunch of stuff to the model, like if you want like attachments and stuff, like if you have like a gun, I don't know if you guys have ever played Escape from Tarkov or anything, but there's like a billion attachments on those guns, so you gotta do a bunch of special stuff. Obviously, me rendering, making sure we can handle it, making sure we can render it correctly. Then there's the graphics driver, which I used to work on, which is making sure that, which is a heavily performance oriented thing, making sure that we can get all this stuff to the GPU, and then your 2080 Ti or whatever that actually draws the pixels on the screen. So that's like the whole process tech stack for like a 3D, for getting your 3D graphics in your game. So that's kind of like the important bit that is the whole thing with this talk is just kind of like, hey, what's the whole process, right? Why do we have graphics? What graphics is? How does it all work? This is how it works. Is that yeah, that is how graphics works in video games at a very high level. So we're gonna shift gears a little bit. We're gonna talk about working at EA. So obviously, EA is a really big studio / publisher. But one, you want to work at EA. If any of you guys are interested in the game industry, you guys are probably familiar with the reputation of the game industry, right? Low pay, crunch a lot. It's a lot of really hard work. Which is why I didn't do games out of college, because I was like, I like money, so fuck that. But EA actually pays pretty well for game studios. I make good money at EA. And I know like I have other friends who work at other game studios and stuff, and they don't make as much. And it's not even like depending on the studio. Like most game studios are pretty small, right? They're pretty small operations. Um, like if you're working on like an indie game studio, you're probably not gonna make money. I'm gonna be honest here. Unless you're like the guy who made Minecraft, you're probably not gonna make money. I'm gonna go say it. Even if you work at like a larger studio, like Activision and stuff, they don't necessarily pay that well. Like I got some buddies who work on Call of Duty. They don't make a lot, but they get to work on Call of Duty. So that's the rough part about game industry. But EA, it's not like that. There's a good anti-crunch culture. You get good benefits and all that stuff, so you don't have to feel like you're dying. And everything's under the EA umbrella. So if you work at like DICE, it's under the umbrella as the studio I work at. So there's a lot of shared infrastructure moving around. So that's cool. There's internal transfers between studios and stuff. It's kind of like I don't know if you guys are familiar with like other big tech companies and how they work, like Google and stuff and Facebook. You can transfer between teams and stuff, or transfer between products you like working on. That's really easy at EA. I know like a lot of the bigger studios, they have like the studio for the game, right? And then the other studio is like a different company. So it's like really hard to transfer. But at EA, it's very consolidated. So that's good. There's a lot of internal resources. Internal, there's a lot of smart people who work at EA and you can talk to them and we share resources across teams. Like we have some people from other studios helping us out on this game, right? So it's really, there's a lot of internal stuff. So EA has a very questionable reputation. I'm sure you guys are already familiar with this. But people do not like EA, at least a lot of gamers. Especially because some PR fiascos like Battlefield 2042. But besides that, it's overall a good place to work. Plus, get like free gyms and stuff, which is really important. I don't know if you guys are curious about this, but if you want to get into graphics, how do you do it? Getting the graphics is extremely hard, actually. It's one of the hardest parts to get into in game dev. I'm sure like most of you guys are working on games, right? You guys wear a lot of hats, right? I remember when I was in school, or not even when I was in school, when I'm working on my own games, when I was working on my games with friends and stuff, we kind of like did everything ourselves, like the audio, the graphics, the gameplay, did all that stuff. But graphics is like a very specialized field, and it's pretty specialized, and there's not a lot of resources to get into it. It's like super hard. I know at like UCR, there's CS 130, which is like the pure graphics class, right? Is that still there? Actually, what year are you guys?
That was there. It still was.
Okay.
Yeah, pretty much like 2 years ago, maybe 1 year ago. It still
Okay.
was there.
So CS 130 is like an intro to graphics. I know like the professor there's Shinar, I think. But back when I was in college, we had Victor Zorden. And that was really cool because Zorden was he had like a whole game dev program, which was really cool. And then he moved to Georgia for another opportunity. So it's kind of rough. But yeah, CS 130 kind of gives you like the intro to graphics, right? But to be honest, CS 130 doesn't really teach you much, actually. It teaches you like the bare minimum of like understanding how stuff gets on the screen. It doesn't tell you anything about how the graphic or how the game industry does things. If you want to get those resources and you're not already in industry, good luck. It was like super hard for me to get the graphics, actually. I spent like years on this to like learn everything. And I did CS 130. I worked a lot with Victor Zord when he was there as the graphics guy. I talked to Shinar a lot. I worked at the UCR Brain Game Center and stuff. I was like, I was trying to get into graphics like in school, and then when I graduated, it was still really hard. And honestly, it's because like most of the information is in behind the papers and stuff. There's no like intro. There's not a lot of good intros because there's like so much stuff involved in like rendering and game engine stuff. There's not really a good way of showcasing all of it to beginners. So it is extremely hard, but if I did it and you guys are really interested in computer graphics and making stuff look good and run fast, then you know, if you work hard, you'll eventually figure it out. It's just extremely specialized and extremely hard to get into. But you know, more and more game companies, they need graphics guys. More and more AR, VR companies, they need graphics guys. So, you know, but if you are going to get into graphics, here's kind of like a quick list: the rendering algorithms, you know, lighting effects, stuff like that. Linear algebra, pretty useful, I would say. Probably required. GPU architecture. GPU architecture is going to be the worst because if you've never worked at like AMD or NVIDIA or something like that, it's gonna be real hard to learn GPU architecture. And then game engine architecture, of course. I have a bunch of books on that stuff. There's like a game engine architecture book I have, and then there's also there's like the Bible in computer graphics. It's called real-time rendering, I think. Yeah, it's by like 3 dudes. I forget who, but yeah, if you're interested in 3D graphics, yeah, 3D graphics, get real-time rendering. That book is amazing. It'll give you the basics at least for everything you want. If you need to get the more advanced stuff, you probably need to read SIGGRAPH papers and look at game engines and stuff. But yeah, that's generally how you get into 3D graphics. But if you want more details, just ping me. But yeah, does anyone have any questions?
Just wanted to say first, like, this has been very informative. I've learned a lot, definitely. So yeah, I think definitely this is, you know, a really great, like, conversation and presentation so far. And I do have a list of questions, but I want to give everybody like the opportunity to ask their questions first before I pick one off my list.
Yeah, that I would guess I can go for it. So I can go. So how hard is it to get into like EA? Because like what do you need to have like on your hand?
It depends. It's like so I don't know if you guys are, this is like a very programming oriented thing. So if you guys are like artists and stuff, this is not very applicable to you. Because I'm an engineer. They like, it's kind of different based on the studio. So you apply to a studio or position, and then the studio is the guy that interviews you. Because I had a few interviews at EA and they're actually pretty different each time. But in general, right, it's like, if you guys are CS majors and you guys were like trying to get into Google and stuff, it's not like that. There's no leak code crap. And honestly, nowadays, if a company is like asking me a bunch of leak code questions, I just don't want to interview with them anymore. Super sick of that. It's a lot of like, if you're doing like a graphics interview, it's pretty like similar, even though the studios all ask different questions and stuff. It's a lot of like knowledge questions, right? They'd be like, how would you render this thing and make it fast? There's a lot of questions like that. Or how would you design a rendering engine? Stuff like that. Which is part of the problem, is that like, if you haven't worked on it already, it's gonna be hard to answer this question. But yeah, it's a lot of knowledge questions and very little like writing code, which is way better in my opinion.
Yeah, got it. Thank you.
Yeah. Okay, so someone asked in chat, how's landing your first job / internship? All right, so I was a very hard worker in that respect in college. I may not have shown up to class a lot, but I was really working on getting like internships and stuff. I actually have a very long story about how I got my first internship, because technically I got it my sophomore year of college, because me and my friends, we got first place at Hack UCI. There's a picture of that somewhere, but we got first place at Hack UCI. We made like this 3D modeling program, and then, you know, some people got interested in us, and that's how I landed my first internship. And then after that, helped me get an internship at Autodesk, and then I started working at Autodesk because they gave me a return offer. So that's how I did it. So honestly, having projects is really good. If you can get, you know, exposure to some companies, that's really good. So yeah, the problem with sort of like at your guys' phase of your life is just getting your resume looked at. Because I'm gonna be honest, that's like if for like entry level stuff, it's like impossible to get your resume looked at. It's like totally different once you get your first job, but getting that first job is really hard. Especially you want to do like something in computer graphics. So you need, you need a lot of projects. You need, if you can get some exposure to like companies like through hackathons and stuff, that can work too. And obviously you need to pass the interview, which is, a whole process in and of itself.
Yeah, very interesting. Something I was thinking about, unless anybody else has a question first. What would you say working for hardware was like compared to software? Like, what was it like working on like a graphics driver compared to, let's say, the mobile game for Battlefield Mobile?
So that's actually a very good question. It initially is like there's a lot of similarities and a lot of differences. Because one, one is you're working with specifically like it's more of like an embedded systems focus, where you like work with a piece of hardware. But the problem with that piece of work, it's not like, but it's not exactly embedded systems. Because honestly, I took embedded systems in college. I hated it. And when we're working on a graphics driver, a lot of it is like making sure that hardware runs really well with applications, right? Because if you're working at like like I worked at Samsung and we were very focused on like how making games run fast, right? Like we had a big focus on Genshin Impact, and like different hardware benchmarks and stuff like 3D benchmarks. So something that so there's a big difference is that there's like hardware focus, right? You're not working with particular application, but there's some similarities because like you want to test like particular scenes in a game, and you do this with both at a game studio when you're working on like a AAA title, and at a hardware company when you're like testing specific scenes in an application and seeing how well it runs. It's just that at a hardware company, you're seeing like it how well it runs on the hardware, and at the game you don't have that. You're working at you're focusing on the content. But in terms of like, and at a hardware company, you're not really working at with like graphics and lighting algorithms, right? It's all performance, 100% performance. At the game company, it's like 70% performance and 30% lighting. But yeah, and at a game company, you work with like artists and content, and that allows you to tailor your stuff more. So yeah, I'd say that's like the main difference is that hardware company is very focused on hardware and making that hardware run really fast with particular games. And then there's even people at hardware companies, they're called dev tech engineers. Like NVIDIA has these guys, like if you're a studio and you're kind of struggling to make your game run fast, NVIDIA will send these guys to you called dev tech, and they'll analyze your game and say, hey, this part of the game, you can do these things to make it run faster on the hardware. And I did that for a little bit, which is fun. So yeah, there's a lot of interoperability. And there's honestly, if you get into one, it'll teach you a whole lot. Honestly, working at a hardware company taught me like so much about GPU architecture, which is like super invaluable. Definitely helped me get through the interview at EA and stuff.
Yeah, very interesting. Oh, I see there's another question in the chat.
Yeah, I don't know those people. Sorry. Yeah, EA is a big company.
Yeah,
I can probably find them on Slack though.
That does make me wonder, what would you say working at a big company is like? Like, do you like the atmosphere of working at like EA compared to like something smaller, even if you maybe not have worked there at a smaller indie studio, but maybe talk to people who work in indie?
To be honest, I've mostly worked at like larger companies. There's a few reasons for that, mostly because I like money. That's probably the biggest reason. The thing with like bigger companies and stuff, you get more resources. Just you get better pay, you get more stability, which is good. But you definitely have less freedom, and things are way slower to move. in a lot of ways. Like at Autodesk, that was like bureaucracy central. So that sucked. Samsung, yeah, you have your Korean overlords, and it's very hard to get them to do things sometimes. So that sucked too. At EA, we have they're very slow to hire because they're concerned about budget and stuff. So that's the big problems with like a big company is that things just move slower in a lot of different directions. So that sucks, but at least you have stability, right? This is a trade-off. You get stability versus like freedom and pay. So yeah.
Yeah, I see. Yeah, that's fair. Yeah, very interesting in general. Because I also imagine like with a larger studio, you have more specialized teams instead of like at a smaller studio, you maybe have like one person with a variety of things that they do. Would
Yeah.
you say that's true?
Yeah, so like yeah, that's definitely the smaller the team and the smaller the studio. You wear like more hats. Like right now, you guys are probably working on games, and I think I mentioned this before. You guys are probably working on a lot of different stuff, right? You're touching every single different field, like getting the art to look right, getting the gameplay look right. There's way more specialization at a big company, definitely. And same thing with startups too. If you guys ever for some reason want to work at a startup, it's kind of the same thing.
Yeah, I got another question. So, like you mentioned, like you're working with mobile. So, like, what is the like difference? Like, kind of what are like some extra stuff you need to do with mobile game?
Yeah, so mobile has a lot of problems compared to like your normal Xbox or PC. Um, the biggest problem that I have with mobile, besides the fact that it's much weaker, is the power consumption and the heat. Um, because phones are smaller, um, they generate a lot more heat. We're having this huge problem because like iPhones, they just like to turn themselves into like volcanoes. They don't throttle themselves at all, so we can't even like make the game run correctly because like after 5 minutes, it just turns to magma. That's a big problem. The heat is a huge problem. Power consumption is a huge problem because like phones have limited battery life. Those are like the two biggest ones. And then this other biggest one is that and this is like the worst actually, is that like there's a lot of different phone vendors. And they all do things wrong. So there's horrible interoperability problems. So yeah.
Yeah, I heard like you even have to deal with like float number because they have different precisions on different devices. Yeah, that's pretty bad.
I'm not super familiar with that, but it wouldn't surprise me because like we've had problems with like different like 32-bit versus 16-bit floats on like iOS and stuff.
I totally believe the heat part. My little brother, in order to like actually play Genshin on his phone, his iPhone, he put an ice pack under it so
Yeah.
that he could keep the phone cool, and it actually did work. It did not thermal throttle with the ice pack, which that was one way of doing it.
I've done that too actually with my work phone because you set the 60 FPS and it just like sucks. Yeah, I've definitely done the ice pack thing.
Yeah, I heard that there is, I believe, one phone that actually has a fan inside of it. And I forgot what brand exactly, but I think it's like Asus or something.
Yeah,
But
I
yeah.
have that phone.
Oh, okay. Yeah, I imagine like that's like the one phone where like because it has active cooling, that's a lot easier to actually render a game. Like especially after like a little while when normally it would thermal throttle.
Yeah, it's uh it's great. It's just very expensive and very big. Most people aren't into that.
Mhm. Yeah, I think yeah, pretty interesting stuff in general. Um I know like Apple with the M1 Max, they're starting to like transition towards like a mobile first architecture in a laptop, which I thought was
Yeah.
interesting.
Um, that works because Apple does not care about games at all.
Yeah, that
Yeah.
totally makes sense. Yeah, so I think in general, like it's cool in concept, but I was like, I like playing games too. So for me that wouldn't necessarily be it, but I imagine that's really cool though for somebody who's focused way more on other stuff than games.
Yeah. Um, Yeah, it kind of is kind of a trade-off. I personally hate Max though. It's just horrible for games.
Mhm. Yeah. Okay. So I guess anybody else have any more questions before I pull another one out?
Um,
All right. So I guess something that I don't know, I guess everybody would be interested in is like what are some of your favorite games? And like would you say like some of those games like inspired you to do programming in general?
yeah, I would probably say that the only like I'm back when I was in school, like the very beginning of like 2012, people got into CS because they wanted to make games, right? And I wanted to make games. I made games in high school. I wrote my own engine and stuff. I did all my 3D modeling stuff, and that's still on GitHub to this very day. And that was why I did CS. When I graduated in 2016, people were getting the CS because they wanted to like work at Facebook and stuff. They wanted to make a lot of money. So yeah, there's definitely that aspect. I want to like anytime I had like a game that was like I had a game idea and there's like no other game, I would just like try to make it myself.
Yeah, really cool. Diane asked, like, do you have any graphics API hot takes?
Are you in the industry, Diane? Okay,
Yes.
that would explain it. OpenGL sucks, obviously. Vulkan is the future of graphics. Um, and no one can write Vulkan because it's super verbose, so everyone just uses game engines instead. Um, but I worked with Vulkan for a long time at Samsung, and honestly, we use OpenGL for Battlefield Mobile a lot, and it's like a nightmare. The synchronization is like awful. It just too much in the like too much different driver crap. Because on mobile, the drivers aren't even in spec most of the time. There's tons of bugs.
Yeah, something I was wondering about now that I think about it. Like, I know OpenGL, like Minecraft on my PC runs horribly, but I have AMD, so I just expected that. I was wondering, do you happen to know why OpenGL is so hard to run on like AMD? Or is that something like an AMD person would know, but like you don't necessarily know off the top of your head?
I am familiar with AMD very intimately, actually.
Oh, okay.
The Samsung GPU architecture is based on AMD's.
Mhm.
Um, it's there's a lot of very deep technical reasons. Basically, the biggest problem with OpenGL is the driver has to guess everything that you do. Um, so it forms like a whole DAG and dependency system. Um, and some architectures don't like that more than others. Yeah.
Wow. Yeah. I think, yeah, pretty interesting. Because I remember before I would explain to people like, oh, I can't really play Java on my desktop because it doesn't run well. And some people who aren't familiar with like hardware would say, well, why? It's Minecraft. It shouldn't be hard to run. I was like, it is, surprisingly.
Yeah. Just because a simple game does not mean it runs well.
Yeah. Yeah, so yeah, that's the struggle of it when you have AMD hardware like that. So yeah. So yeah, it's pretty interesting stuff in general, I'd say.
For sure. Does anyone else have any other questions? Otherwise, I can just go to the next slide and just.
Yeah, I'd say if nobody else has any more questions, like feel free.
Okay, this is the last slide. This is just like a contact me thing. So you can contact me at Discord. I'm in the Gamespawn server. You can email me if you want. You can add me on Facebook or whatever. You can also add me on LinkedIn. You can message me. I'm more than happy to help, especially as a former Gamespawn alumni and former co-founder. Very, very happy to help. Honestly, Gamespawn seems a lot bigger and a lot cooler than it was when I graduated. So, feel free. I have, no problems helping out. Very happy to help.
Yeah. So yeah, I say this has been a pretty great talk so far. So about to end the recording soon. So I guess like everybody just give like a round of applause or whatever. So yeah.